Okay, I'm Rob Kaufman, and I'm speaking about Tanning Bed, which is a new search library I've been working on. My ability to work on this is made possible by the AssayDepot.com, and I run a consulting shop called Notch 8. So what's Tanning Bed? Or why Tanning Bed? Tanning Bed is because models are too sexy to be out in the sun. Or because models are too sexy to be out in the sun. Tanning Bed is an interface to Solr, a Java-based search engine. Solr is kind of a ready-made solution. You can just drop it under your system and talk to it via HTTP posts and GETs. And so it's a pretty powerful engine. It's used by a lot of really amazing sites. CNET uses it for their search. It uses the Lucene search engine as its core, which is maintained by a lot of really top-notch folks. IBM has a substantial stake in it. There's a lot of development being done there. There have been Solr interfaces for Ruby before. A big one was Axis Solr. So, why not just use that? Why not just recycle it? Well, one of the things is the project I'm working on right now uses CouchDB, which there is no ActiveRecord front end for CouchDB. It's kind of a whole different concept than the regular RDBMSs. CouchDB is a document-driven database. So that's, the fact that Axis Solr only works with ActiveRecord was a major problem for us. Also, if you go to the homepage for Axis Solr right now, you see this GoDaddy ad, which never really instills a lot of faith in a project and the activity of its development. So why are we using Solr? Why not use Sphinx? Thinking Sphinx and Axis Sphinx, and there's several. Alter Sphinx, thank you. Sphinx plugins that do a really good job of providing a Ruby interface for Sphinx between your model objects. However, Sphinx itself is very centered on the idea of relational databases. It's highly optimized for that, and it does. It's blazingly fast at doing that, but it means it doesn't really do a whole lot else. Record indexes in Sphinx must be numeric, and if they're sparsely numeric, Sphinx is really slow, really fast. You can put. If you put 10,000 records in and they're numbered 1 to 1,000,000, your Sphinx install is basically worthless. It's slower than just looking it up in your database at that point. It just doesn't function well. And our keys happen to be hashes. So, that's not a numeric value. And if we're trying to bounce back and forth between them, it's just asking for pain. Also, your facets, you must know what your facet fields are going to be ahead of time with Sphinx, and that was something we wanted a little more flexibility on my project. And also, the third thing is this particular application is going to have some distributed components, and Solr allows us to run one or more search engines on a network very easily and then talk to them from across the internet without sacrificing speed or having to open up sockets or do any of the more complex things that you might have to do if you were using a standard Sphinx install. We don't want to have to deploy the search engine to every single place we want to deploy this site. So what were the design goals? The idea behind this was to make something that was really Ruby. It didn't have a lot of Rails tie-ins. It wasn't tightly coupled to ActiveRecord or to Data Mapper or even to CouchDB. Something that was really accessible from a Ruby class in a really comfortable way. We wanted to keep search away from the data store. We didn't want SQL or this document-driven database to be an imperative for this library to work. We wanted whatever your data is, even if it's just text files, to be able to put it in and out of Solr easily. I wanted to make it simple. I didn't need massive complexity. However, I did need some complexity. We need facets. We need to be able to update records. We need to do some things that do have some mental energy in them, but I wanted the interface to be really clean and not get in your way. And I wanted to use the Solr Ruby bindings. The Solr has very good bindings for Ruby, and there's no reason not to take advantage of those. Yes, you could go out and just, you can put records in and out of Solr with curl if you want to. But there's no reason to go back to basic principles if you have a nice binding right there that handles all of the communication. However, the way the Ruby bindings work is it's not like a binding into Java or a JRuby library. The Solr team maintains a separate set of this Solr Ruby library that talks to Solr over HTTP and provides you Ruby objects on the other end. So how is it used? You can just install the gem. Right now it's up on GitHub, and there'll be a link to this at the end, and it is a gem. You can just go gem install. You make sure your class has 3 methods. That's all we're saying, like, you have to be able to do. It can be any generic Ruby class as long as it has an ID, as long as you can call .get on the class, and as long as it has a Solr keys method. The Tanny embed will throw a nice clean exception saying, hey, I didn't find a Solr keys method. You need to implement one in your class if you don't have it. And then you set up a save hook, or however you want to do it. Maybe you don't want to add things to Solr all the time. You only want some records in Solr. You have a lot of flexibility there. So let's look at an example. In this example, we're looking at CouchDB. CouchDB already has get to retrieve records, and it already has ID, so we don't have to define those. It has a method called keys, which gets you a hash of all of the elements. So, for instance, this particular table has a name field and an address field. So keys would return a hash with :name, :address, and then the values. And that's it. That's all you need to be able to add records to Solr. Here we see an ActiveRecord model, which probably more people are familiar with. Get is very analogous to find. It's just the HTTP terminology instead of the find and find all terminology. And then Solr keys is completely analogous to the method attribute names, which also just returns a hash of the name of the field names and their values. And we can include it and off we go. There isn't any other real setup you have to do to use this. So how do we call a search? Well, we can say if we want all of the models that we've included in our Solr store, we can say tannyembed.solrsearch. Our query, if we wanted to find various facets, we just call them here. So we say facets, fields, and then the name of the fields. You can list as many facets as you want, though you will pay for performance. Oh, facets are, I'm sorry. Thank you. Facets are, for instance, if you have people, and the people work for companies, and you want to see how many people are in each company in your search results so that you can drill down. So say maybe, 5 people work for the Assay Depot. I would then click on Assay Depot and it would take my search results and narrow it down to that set so that you can kind of drill into your data. Does that make sense? It's kind of like an SQL subquery where you're taking and you're taking your result set and then you're moving down to the next layer. So if you only want to retrieve one model, you can do that by including Tanny embed. We got several class methods, including Solr search. And this also, you can do facets on just the model, and this will only return keys for the model that you called it on. So what does the result look like? What you get back is this construct called a Solr results, and then that has data in it that shows you a hash of all of the keys. This same construct has facet counts. So for instance, in my example, it would show you company 1, 5, company 2, 6, so that you can display those in your output. And you can, if you want to just generate models for all of your results, you can call the Solr load method, which will return to you instantiated full models. The reason we do the keys separate from the models is one thing you can do if you have very large data sets is you can put only the information you want into your result set. So for instance, if I don't want to spend, an hour instantiating 5 million records, when all I really want is their ID and their name, then I can do that with Solr very easily through this interface. And that's why it's 2 calls to go ahead and load up your items. Because really, if you're bothering with a separate search engine, you're talking about enough data most of the time to make it worth going to that extra work, to farm it out to a specialized store. And that usually means enough records that you don't want to spend a bunch of time instantiating all of them. So, Solr, like I said at the very beginning, is in Java. Does that mean it's really hard to set up? Do you have to deploy Tomcat? Do you have to do any of the really complex things that you hear horror stories about in getting some Java apps up and running on the web? The answer is really no. Tanningbed bundles a version of Solr in an effort to just maintain compatibility when you're downloading it. It does make the gem a little large. And if you did have a freestanding Solr, it's really trivial to redirect and use that version of Solr instead. But I feel that bundling it gives you so much more speed out of the box. Like you can be up and playing with this in a few minutes and not, spending time trying to figure out how to deploy Solr, which might be well out of the realm of what you're experienced as a Ruby developer. So from the Tanningbed gem, you can just call rake Solr start, or if you want a separate instance for testing, you can call start testing. Stopping it is rake:stop, Solr rake:stop. It's really just that simple. As long as you have obviously a JVM installed on your system, which most developers do at this point. I mean, everyone on Macs, you're good to go right out of the box. A lot of the Linux distributions come with them now. So I guess I just feel like that one JVM requirement probably isn't a total killer for your dev box. So what might the results look like? This is a screenshot of the Acid Depot site we're developing. We can't really see it super well. I was hoping it'd be a little bigger than that. But we just see, it looks like search results. There's a listing there, and links. This page doesn't have the facets displayed yet, but that is definitely something I could show you real quick. So how complicated is this library? It's 142 lines of code. Now this doesn't count test cases or any of that, and there's more lines of test cases than there are lines of code, but that's it. It really just isn't that much. Mostly what I'm doing is wrapping up the Solr Ruby bindings in an easier to use package so that you're not custom making all of these calls all the time. This is where it's located. Feel free to email me if you have any questions. You can send me messages on GitHub. They just come to my email, so I don't really see why that's different. I'd be happy to help anyone if they're interested in getting set up. And that's it. So, oh, and one more. No, that's it. Anybody have any questions? Sure, I can do that. Hey, look, I left it running. Go me. Okay. Let's searching for biology. Now you can actually see the site this time. So you see this is our result set. And then, obviously, I have not properly styled this page yet, but that's okay. Here are our facets. We have a catalog. Can you guys see that at all, or is it looks really washed out from where I'm standing? Okay. I can make it bigger. I don't know how to make it darker. Is that a little better? Okay. So we can see that in toxicology category, there are 13 results. If we add these numbers up, we will find that this number equals the number of results we were returned. We see that we're divided the results up also by providers in the same query. So this is all one search call to get the result list you saw above, and then these. And we see, that again, we have numbers next to each one showing us the counts. We can click in and see how many MDS USA records we have. And we see that we got a subset of our original results. And that's really all there is to it. I mean, it seems like such a simple thing, but when you're trying to pull it out of your search repository, it tends to be a lot more complicated than it has to be. So it's nice to be able to, just go through a hash and generate these lists easily. Yes? Yeah, see, we see also try down here, though they're not showing counts at all. Right, no, that's just one possible aspect. But this is, again, it's the same concept of drilling down into more specific results. See, and then we continue to get more detail as we go in. This is a UI trick. This is becoming incredibly popular. Just because it really allows you to... it allows your users to find stuff they wouldn't find otherwise. We all generally assume, everyone has to be really good at searching these days, but a lot of people still aren't. And they put in words that don't really mean what they want, or that maybe whoever was inputting the data didn't, think to use. And that, they can feel really lost. And, when you try and find something on a website and you get 0 results, it's kind of a helpless feeling for most people. Like, they don't just think, okay, I need to add a different word, or I need to change things around. They stop. And so if you can do things to prompt them to dig deeper, or keep looking, or try something else, then, you can really improve your user experience. Any other questions? All right, thank you guys very much.
That concludes this episode of the SD.RB podcast. See you next time.